10-15 years back. Okay, when we go back to 10-15 years, we used to have only physical servers. Okay, not about virtualization, not about the from 1996, 97 or also earlier of 2000, we have introduced with the virtualization concept. But before that, we don't have these virtualization concepts. We used to have only physical servers. So whenever we are having these physical servers, you know that the physical servers are created by the physical hardware like CPU, RAM, and hard disk. Now, if you can see, that is what they are saying. And there will be dedicated physical server for each and every application. If you are running an application and that application will be dedicated to a single physical server, it won't be on the multiple physical servers. Okay, or else inside a single physical server, you cannot create the multiple applications. Okay, it will be dedicated to a single application. So whenever we are doing this, then there will be a problem. So the main problem is, or else we discuss about the first of all benefits of that. The main benefit of this physical servers using the physical server is high consistency will be there. So if you take an example, now we are having internet of two types. One is wide internet and the other one is wireless internet, or we will call it as in short as Wi-Fi. So we are having wired and wireless. So as per your knowledge, which internet will be very faster for you, whether the physical one or else the wireless one? Yes, any idea about that?
Wireless.
Why? Sorry, come again. Okay, so here we will be having the wide communication will be very faster than the wireless communication. In the same manner, not only that, for example, if a dedicated server for you, if a dedicated physical server is there, and this dedicated physical server, whatever the resources are there, the total resources will be dedicated to that particular application only. So that whenever the application requires high RAM or else high CPU, automatically that can be provisioned. But the point is, the same is the drawback of the physical servers. What is that? The drawback of the physical servers are, see here. So physical server offers high performance and low latency since they are directly accessing the hardware, since the applications are directly access the hardware resources. However, they can result in a underutilization. So see here, I used to work for a banking company. I don't want to name that, but yes, there is a banking company where I need to start my servers on somewhere around 2014 and 2015 times. I have to start a server. I have to start multiple servers at the time whenever we are starting every day at 9 o'clock. Stock market will be started. So when the stock market is started before 9 o'clock, like 7:30, 8 a.m. onwards, we have to start all the services on the server. So whenever we start the services on the server, exactly at 8:45, every testing should be completed. And by 9 o'clock, the stock market will be open. So whenever the stock market is open, at that particular point of time only, you will have huge load on the server. Apart from that, throughout the entire day, the load won't be that much high. And at the time of closing also, there will be load. So at exactly at 3:45, the markets are going to be closed and we are going to stop the services by 4 p.m. So at that particular point of time, the load will be very huge. So starting point at the starting day and at the end of the day, you will have the huge load. But if you see the entire day, you won't have the load on those servers. Not only like that, if at all, if you are running any application on a server, the application will not have the consistent load. Consistent load means the constantly heavy load won't be applied on the load, so that the application won't be accessing the huge amount of traffic. So it is not going to be consuming the huge amount of resources. So there will be a limitation, a limited resources will be consumed. So what happens here, due to this, there will be underutilization of resources will be there. So as we are having underutilization of resources, so there will be a lot of, so see here, this is what the drawback that they are saying. As an individual servers often run at a fraction of their capacity, leading to the inefficient resource allocation and increase in the operational cost. Whenever you are working with the physical servers, the cost of the physical servers will be very high when you compare to the virtual servers, or else when you purchase a single server and you are running the virtual machines on that, the cost will be very less. But when you come back to the normal physical servers, if you want to run a single application, you don't need to purchase the entire server. If you purchase the entire server, there will be huge amount of cost, or else huge cost will be there. You have to bear heavy expenditure. So this is the main problem with the physical server. So if your application is running on a physical server, again, I am quoting that in a single sentence. If you are running an application on a physical server, then that server resources will be underutilized. So due to that, the operational cost will be very high. Even though you are having best benefits from the physical servers, still the operational cost will be very high. And as well as, the one more point is, if you are running a single application, now you want to install another application on the physical server, that won't be happen. Why? Because there is an operating system. On the operating system, for example, you are running Java version, some 1.8 is the application version which you are running. Suddenly, I want an application which need to have Java version 8. Okay, Java version 8 or Java version 11. So right now you are running an application on a physical server with 1.8 version. Suddenly you are deploying a second application which is having a version rate that is 8. So if you compare this two application, now what I'm saying here, if you see here, this is your, now we are having a server, and in the server you are running an application one, app one. So whenever you are running app one, so that application might be running on Java 1.8, Java 1.8. But we are going to create another application, that is app 2. Okay, so we are about to install this, but here application 2 is there, and it requires Java version 8. So what you have to do now? So there is another strategy that we can implement that we cannot do in this situation, but in the most of the cases we can do that. But I don't want to say you that. Yeah. So yeah, when you're coming back to this here, this application, either this app one has to be upgraded to version 8, or else this app 2 has to be downgraded to version 1.8. If this application is upgraded to 8, then it won't work properly. If this application is downgraded to 1.8, then this application won't be working properly, which means that there will be a compatibility issue. So to overcome all these problems, operational cost, version compatibilities, and all the things, what IT industry, the big IT industry people thought that, so what is the solution for this physical servers problem? So if you want to purchase a physical server, that will cost you around 4 lakhs. Okay, minimum physical server configuration will be 1.5 to 4 lakhs. So is that a very good method to purchase all that? So we don't have that much amount of money. And one more thing here is, for example, there is so if you see here, I am having an application inside a server. I am having an application and it is running good. So the load on that application is slowly, gradually increasing. Every day to day, the load on that application is gradually increasing. Whenever the load on the application is gradually increasing, so we can adjust as per the loads. We can increase the resources inside the server. So for example, this server is having some 16 CPU, or else let me do one thing. First of all, I'm having 8 CPU and some 64 GB of RAM is there. For this server, 8 CPU, 64 GB of RAM is there. Now, what I can do, if the load is suddenly increasing, then it's okay. I can I can manage that. So I can increase the CPUs. But when but there is a suddenly rise in the load. So if gradually increasing, I can stop the load for some time and I can increase the resources. But suddenly, due to a sale or else due to any exciting offers for that company, suddenly the load on this server is increased. Okay, then what you will do? We don't have anything to do. So automatically what happens, the load will be increased. When the load is increased, then at a particular point of time, this server will be stopped. The server is going to be stopped. So it is going to be in the hang state. So I don't want that to be happen. So for that reason, what I can do here is, I have to create another server to load balance. I have to configure another server. Now, can we say that every 24/7 the load will be constant? Again, we cannot say that. If the sale is ended, for example, let me frame it like this. Now nowadays you are going to experience the Amazon Independence Day sale or else Big Billion Day sales from Flipkart and Amazon websites. At that particular point of time, what is the strategy of that particular vendors or else particular website owners? They will be collecting the servers before 1 month. They will be purchasing the servers before 1 month. They will be reserving the servers before 1 month. And what happens? They will deploy, they will configure all the tests, and they will deploy the applications on those servers. When they deploy that, so that's okay. Right now, I'm telling about the right now situation. But when you go back to the previous years, in the good olden days, what they will do? So they need to have this own servers. Right now, we are having cloud technology and virtualization technology. So at that instant, we will be increasing the servers. But when you go back to the good olden days, whenever you are using the physical servers, suddenly, if there is a huge load is increased, then automatically I need to set up another server. Is possible? No, it is not going to be possible. So what I need to do, I need to maintain a standby server aside. But what is the operational cost? So if this server is purchased with for some 4 lakhs of money, again I need to purchase the same identical server with 4 lakhs of money. So which will be, that's, if you think that this is the main server and it is running good, so that's okay. So now if you see here, this server will be utilized once in a year. Or else you can ask me why we need to utilize that once in a year. Why can't we run daily? If we run daily also, that much load won't be there. So the load will be shared and the resource will be underutilized. That is not my requirement. So this is main drawback of your physical servers. Whenever you are working with the physical environment, this is the main drawback of your physical servers. Are you able to understand? Are you able to follow the flow? Is there any questions? Is my flow is okay for you, or else do I need to slow down a bit? Okay, fine. So now I don't want these many number of physical servers, or else if I have this, this is the main problem. So to overcome this, what we are doing here is we are going for a new form of technology called as virtualization. So we are into the virtualization. What is this virtualization? What virtualization will do here is, whatever the physical platform that you are having, I'm going to divide that physical platform among like into multiple virtual machines. Now here you need to understand how we are going to divide that. Just let me give you an example so that you can get a clarity on this. You are having a hard disk. Let us suppose think you purchased a hard disk. Now when you purchase this hard disk, the hard disk size is of 1 terabyte of size. So you don't want, see, that 1 terabyte size of hard disk you have installed on your computer. Now, whenever you have installed that, you thought that why I need to go with this 1 terabyte? Why can't I divide this hard disk into two different partitions? One will be reserved for the system partition, and the other one will be for my personal folders and all the things. We can keep that. Now, whenever you think that, are you going to open the computer and you are going to break the hard disk? It is not going to happen. But what you are going to do, you are going to virtually divide that hard disk into two different partitions. You are going to divide that, you are going to break that logically, not physically. In the same manner, now you are having a server. Now you are having a server of size, some 64 GB of RAM or 32 GB of RAM, and some 4 CPUs, 4 CPU cores, and or else 8 CPU cores. Okay, and somewhere like 32 GB of RAM is there. So for this server, if I want, this is the physical server requirement which I am having, or else this is the physical server hardware which I am having. Now inside this physical server, if I want to install my applications, now what I am thinking, I don't need 8 CPU and 32 GB RAM for my application. If at all, if I am having some 4 GB RAM or also 2 CPU, that's more than enough. Now what I can do here is, by installing a virtualization software, like VMware ESXi, or as Citrix Gen servers, or Citrix, or else if you are having a client mission, that is altogether different thing. Let us supposing we are on the server, so I can use VMware ESXi. So this is the middleware which or this is the software which I'm going to use. And using this software, what I can do here is I can divide my physical servers into multiple virtual machines. So here, this is the VM1. So where I can run. So this is a separate operating system. This will act like a separate computer or server. And here I am having virtualization VM2, and there will be VM3 and VM4. For example, see, now you are in your home. Now you are having, so you are two siblings. Okay, you and your brother or sister is there. So everybody will have the same requirement. For example, you are a working professional, so you don't need the pocket money. But at any particular point of time, you might be asking some money from your father, but that will be very less. And your brother and sister might be studying. They might require to travel, or else to explore something, or else to study, to buy the books, or else to buy a brand new clothes and all things. They need to depend on your father. So which means that here also, if you see here, these are the virtual missions. Each and every virtual mission will have its own need. Okay, each and every virtual mission will have its own need. Now this virtual mission might be running, my VM1 might be requiring, or else might be running a database. For example, this might be running a DB. Either it might be an SQL DB, or else Postgres DB, MongoDB, any type of DB, it will be running. Now this virtual server require huge hardware. Like this, to run this database, I require somewhere like some 4 CPU and some 16 GB of RAM is required. So now who will provide that? So the requirement will be collected by my virtualization software, like my VMware ESXi. It is going to collect my requirement and it will send it to the hardware. So this virtual machine requires this much amount of hardware resources. Now what my hardware resources will do, it will allocate the whatever my required things are there. So it is going to allocate for me. So here this will act as a communicator between the virtual machine. Your VMware ESXi will be acting like a communicator between your virtual servers and your physical server. Okay, so that's about your virtualization. And this physical server, this virtual server might be running some web application which requires 1 CPU and some 2 GB of RAM is sufficient for to run the web application. For that, again, it is going to request the VMware ESXi and it is going to get the resources from the physical servers. And if you go in deep into this, there will be a lot of things that you need to understand in the virtualization. But it's a basic thing. Okay, so these virtual machines will be requesting your physical servers, and physical server will provide the required amount of resources for your virtual machines. Now, like that, what is going to happen here? Each and every physical server will be getting the resources from the physical, or else each and every virtual servers will getting the resources from the physical servers. Now, this is okay. This is the main point for your cloud. When the cloud was introduced, the cloud platform totally depends upon the virtualization only. The base of your cloud will be your virtualization. Whatever the AWS EC2 instances that you are running, or else Azure VMs you are running. VMs means virtual machines. Everything is considered as a virtual machine only. Your EC2 instance is a virtual machine. Your Azure servers, or else Azure instances, or else Azure virtual machines. Simply they can call it as a virtual machines. They are also the virtualized machines only. So the total instances whichever you are deploying on your cloud are the virtual machines. So virtualization is the platform for your cloud computing. Okay, so now why we are talking about this? This is about two types of virtualization. Whenever we are discussing about the virtualization, there are two types of virtualization. The first one is hardware virtualization, and the second one is software virtualization, or else OS virtualization, not about the software, OS virtualization. So what is this virtualization? Just now, whatever we have seen here, dividing my physical hardware into the virtual machines is called as a hardware virtualization. There are two types of virtualizations in hardware virtualization. The first one is type 1 hypervisor, type 1 Hyper-V, and the next one is type 2 Hyper-V, or else type 2 virtualization. So type 1 means this is also known as bare metal virtualization. This is also known as bare metal virtualization, and type 2 is also known as hosted virtualization. Hosted virtualization. These are the two types of virtualizations that we are having. Now, bare metal virtualization in the sense, now you will have a physical server. On the physical server, directly you are going to install the VMware or else any virtualization software. Now, if you see here, basically you will have the hardware. On the hardware, you need to install the operating system. But on the bare metal virtualization, you don't need to install any operating system, VMware, or else any virtualization software that you are running that will act like a operating system itself. So this virtualization software will create our servers. So this is called as a bare metal virtualization. Whatever you are seeing right now, this is a bare metal virtualization. Or else I can show you in the another manner like this. There will be a server hardware. On the hardware, directly I am going to install my virtualization software. On that, I am going to run some virtual machines. Okay, some virtual machines. On the virtual machines, I can deploy the applications. So this is my bare metal virtualization. You can go through the any images from the Google also, you will find the same. Okay, hardware. And this is my virtualization software, like virtualization. Okay, so the best examples will be your VMware, VMware ESXi, and the next one is Citrix. And here you will be running some. This is my VM1, which will be having bin, okay, /bin, or else bin directory binaries, and all the executable files will be there. For example, this might be a Windows virtual machine. Okay, and here this is VM2. Whatever we are discussing here, this is my VM2, and it will have its own binaries. And this is my Linux operating system. The kernel will be Linux kernel. Now, on that we are going to install some applications, app1, and here you will be having app2. Okay, this application belongs to Linux version, and this application belongs to Windows. So this is how your bare metal virtualization will be there. And when you come back to the next type of virtualization, that is hosted virtualization, where you will have the similar configuration itself, but in between hardware and your virtualization, you are going to get another layer called as operating system. Okay, this will be mainly used for the client side. Okay, whenever you are having any desktop or PCs or laptops, there you are going to use this type of virtualization. But primarily in the servers, most of the companies will be going with the bare metal virtualization only. Okay, so here you will be having softwares like VMware workstation, guys. VMware ESXi is for servers, and VMware workstation is for the clients. And VBox, VirtualBox, it is given by the Oracle. And the next one will be KVM, kernel based virtual machine. This will be, you can see this on your Linux operating system. These are the different types of virtualization technologies or else virtualization softwares you are having on the type 2 hypervisor. This is the main difference. Now, where we are, this is about your hardware virtualization, where we are going to divide our physical server into multiple virtual machines. Okay, any questions here? Did you understand about this hardware virtualization? Any questions? Is it clear? Can I go for next one? Okay, right. Now let us go for the OS virtualization. What is this operating system virtualization? So whatever we are using in our process, or else whatever we are running on our operating system, those are all the virtual processors only. Now, this operating system virtualization is primarily called as containerization. Containerization. Okay, what is this containerization? If you can see here. So there you go. Virtualization technology. Now, if you can see, these are the different types of virtualization. And here operating, also known as containerization or operating system level virtualization. This is a form of virtualization allows multiple isolated user spaces known as containers. So what is this containers? Okay, what is this containers? So if you can see here, we are running containers on our operating system. Now what they are going to do here? Now this is the main concept which you need to concentrate. Now I am having a server. On the server, I am having an operating system. Either it might be a Linux or Windows, any type of operating system we are having. On that, what we are going to do here is, here we are going to run some, this is my operating system. On this, I am going to run some containerization engines, okay, or else container runtimes. Okay, container runtimes will be running like Docker or else containerd, or else we can go with the Rocket. These are all the container runtimes. Whenever we are running them, so on this, we are going to run our containers. So here you need to understand one thing. The point is how containers will be running. You are saying that the containers will be running on this and all the things. How they will be running. Here we are having a very good documentation. Come on. What exactly is a container? Okay, if you see this document, you will find out to be a very good document for you. Here you can see. So the word container doesn't mean anything super precise. This is not a very like what I can say rocket science to understand. Containers are just the basic things. See here, basically they are a few Linux kernel features that let you isolate processes from each other. So simply what I can define, a container is a process that is running on your operating system. Like see, if you see here multiple processes are running. Notepad is a process. On the back end, some process will be running to start this notepad. Visual Studio Code is a process that is running, or else that should be started to run the Visual Studio Code. Google Chrome, for this Google Chrome also, on behind there should be some process which need to be started. So what I want to say here, for every process that is running, each and every process is isolated from another process. In the same manner, your containers are also the isolated processes. So each and every container will have its own application running. So one container will not, what I can say, interfere with the another container. So if you can see here, two containers are in the isolated environment. Isolated in the sense, again, don't think differently. They will not communicate with each other. They will communicate with each other if you want. But by typically what I can say, they will be working, they will be acting like a two isolated computers. For example, you are working in a company. Now you are all connected to a network. In your company, you are all connected. Your computers are all connected to a network. Now, some employee will be working with the testing projects. Some employees will be developing the code. Now, whether all the computers are not connected internally, if you see in the physical manner, they are all interconnected. So if one computer wants to communicate with another computer, they can communicate. But physically, if you see, they are isolated. So the processes that are running on one computer will not be equal on the processes that are running on the second computer. They are two different processes. Okay, in one computer, I can run my virtualization servers. In the another computer, I can run some Java related applications. So both are not same. Okay, so here also the same thing will be repeated. The containers are also looking like the same. So the containers which are running on your operating system will be the same, like your distinct laptops or computers which are working on the common workspace. So here also the containers which are running on your operating system, if you see that the operating system is looking like an workspace, if you take the example, and the containers like your computers, each container will have its own application to run. So one container will not interfere with the another container. If you want, then we can do that. For example, I am having a web application. I am running a container with an web application. Here I am having a Python application. Now what I want to do here is, I want to send my data. I want to send my user data into my database. Then what I can do, I can create another container with the database. With the database application, I can create, either it might be a Postgres database or MySQL database. With any database, I can create a container. Now what happens here, when the user try to access this application, he can provide the data into this container. He will be communicating with this container only. Why? Because the front end will be available from this container. and this container has to communicate with the another container to store some data. Whatever the data that is provided by the user, that will be stored on the database container through the application container only. So there you need to have a communication. So what I want to say here, containers are isolated processes only. If you want to establish the connectivity, you can establish that. Okay. Yes. So somebody is unmuted. Any questions? Alok, I think. Alok, do you have any questions? Okay, good. You are unmuted. That is the reason I'm asking you. Fine. So this is about your containers. Now, which operating system, or else what is the engine that will be holding all these containers? That is the Docker and RKT. Or most of the Kubernetes classes, we won't be seeing the Docker. We will be working with the container D only. Okay. Now, let us see what happens and how we can configure these containers and what will be happening in the backend, and how to deploy the container in a virtual machine, or else how to deploy the containerization or else containerized application like Docker in a Ubuntu machine. Okay, let us see that. So for that, what I am going to do here is I am going to use my AWS console. Okay. So if you want, there will be several questions for you. See, the questionnaire that I am expecting here is, sir, I am installing Docker on Windows Server or else Windows machine, and I am running the Linux containers. Is it possible to run that? I'm expecting some questions from you guys like this. I don't know why nobody is asking a question. Okay. See, Docker can be installed on any platform. Either you can install on the Windows platform, or else you can install on the Linux platform also. Now, whenever you are installing the Docker on the Windows platform and you are running the Linux containers, how they will be running? So what I am saying here, containers will use the containers whenever we are running the containers. So here I am running the container. This container will be using the operating system kernel. So what is meant by kernel? Anybody can explain this? What is the kernel? Do you know what is meant by this? I think there are so many working professionals are there. So definitely I think at least 1% or 2% know about this kernel. Anybody know about the kernel? What is a kernel?
For Linux, Unix commands kind of kernel is there, and it's a kernel is a small group of programs which is be run on top of the hardware to boot up and to run the to make the all resources available and to be like a mediator between the hardware and
Okay, very good. At least
is it communication between hardware and whatever the commands we are typing it on the CLI? Is it correct?
Okay. Your way of answer is that is okay. That's fine. So is it correct or wrong? It's a secondary thing. That is your way. That is your way of thinking. That's good. So I don't have anything to say about that. But yes. So whatever you have tried is almost correct. But here we have a small thing here. The point is, whenever we are working with the kernel, whenever we are working, or else whenever we are working on any computer, see here. So first of all, the user will try to communicate with the directly. He won't be communicating with the hardware resources. For example, here I am having the hardware resources, and the user won't be directly communicating with the hardware. What he will do, in between the user and the hardware, there will be an operating system. So he will provide the commands in the operating system. For example, this is your operating system. Now the user, whoever is working, he will provide the commands to the operating system. And what operating system will do? So operating system kernel won't be working. Kernel won't be converting that commands into the hardware understandable language. Here, what will be there inside the operating system? There will be binaries. So these binaries will be acting accordingly. So the binaries are nothing but, or else binaries are also known as what I can say, compiled code. So what is meant by compiled code? A compiler is a it's like a bridge, like it is going to convert the user understandable language into machine language. So binaries are going to convert the whatever the bin folder or else binaries folder that you are seeing in your operating system. These are the not the recycle bin, guys. Again, I know that there are several Windows guys out there, they will think bin means recycle bin, but it is not a recycle bin. Bin means in the server language or else operating system language, bin means binaries. Okay, especially if I say recycle bin, then that is a recycle bin or deletion point. But here bin means direct binaries. So what is meant by a binary? Binary is a compiled code. So when the user executes any command, for example, if I want to create a directory, I will go for mkdir. Now when I give this command mkdir, this command will be executed in the binary directory. It is going to check in the binary directory whether mkdir command is there. If the mkdir command is there, it's a compiled code. There will be mkdir, what I can say, compiled code will be available. So with that, what happens? This binary will forward that command to the hardware. This binaries will forward the command to the hardware, and hardware will process the request. So what user is requesting? User want to create a folder. So it is going to create a folder and display in front of us. But here in between the binary and hardware, here comes the main point called as kernel. Here comes the main point called as kernel. What is this kernel going to do? The kernel will do memory management. Okay, memory management and process management. Whatever the management things are there, everything can be done by your kernel. So which means that, for example, for example, if you see in my operating system, I did not started only a single application. I am not working with only MS Paint. Here I'm having Zoom, and here I am having Firefox. I am running the Visual Studio Code, PowerPoint, and all the things. Now, how computer will know that this user is trying to access this particular application? So that will be done by the kernel. Now, what happens here? Whenever we start an application, so the application will be sent to the kernel, and kernel will understand how much RAM it requires, and it is going to send it to the hardware. If you have this much amount of RAM, the application will be stored inside the RAM. And after that, at that point, inside the hardware, in the processor, some another application might be in process. Now, once this application is processed, automatically the application will be forwarded to your process. This management, the processor management, is also conducted by your kernel only. So here, kernel is the backbone who will say that how to manage, when to manage, what to manage, what you have to manage, which application you have to manage, when you have to process that, when you have to store that, when you have to give the result. Everything will be managed by your kernel only. So kernel is called as your backbone of your entire operating system. Without kernel, operating system won't be created. You can create the front end. You can create, see, it is like a web application which need to have the dynamic configuration. For example, if a user wants to sign up, then if you write only front end code, so I am telling in the development process, if at all, if you write some front end code and you will give username and password, whether that username and password will be stored in the database. Are you able to understand what I'm saying? You have written some front end. For example, let me show you. I'll go to some facebook.com. If I go to some facebook.com, when I provide my username and password and click on login, automatically it will be transmitted, or else it will be validated through the databases. What I need to have in between the front end and with my database, I need to have an application. Here also kernel will be acting like that. So whenever user gives any command, that command will be checked in the bin directory whether the command is there or not. And after checking if the compiled code is there, that will be forwarded to the kernel, and kernel will do the memory management, process management, storage management. Everything will be done by the kernel, and this kernel will forward that to the hardware. So this much important is your kernel. So understood about the kernel? Any questions? Questions? Guys, understood about the kernel? Any questions? You can ask me now.
Sir, where is the kernel program then?
Sorry?
Where is the kernel? Because bin folder we have, I know, but kernel where it is within the operating system software is there.
No, it's a backend. It's not a
Okay.
visual program. Every program won't be visual to you, right? Okay, it's a code that is written. So if you have the, what I can say, the system code, okay, the main code you are having, there you can find the kernel, not in this. So you are having the code which you can visualize. So if I say that, so I can see this application, where is the backend application? What is the backend application that is written? Can I see that? Source code, can you see the application source code?
No, sir.
Are you able
Here
to
we
understand?
can't see.
In the same manner, this kernel is also written in your source code only, in your operating system source code. Okay. Yeah. Right. When we coming back to the next one, so this much important is kernel and your Linux operating system. So what is the generations or how Linux operating system has started? Do you know that? So first in 1970s and 1980s, earlier of 1980s, there are two persons called as Ken Thompson and Dennis Ritchie. Have you ever heard the word Dennis Ritchie? I think so many people might heard about this word.
C language. C language.
Exactly. So he is the developer of the C language. So Ken Thompson and Dennis Ritchie, both of them collaborated, and with the help of some low-level languages, including C language and some low-level languages, they have developed an operating system called as Unix. So Unix. So when they have developed that, they have given Sun Solaris, AIX, and these are all the Unix operating systems which are running. Now, what they have done here is when they developed that, they said that this operating system is a premium version operating system, which means that you have to pay for that Unix operating system. Now, there is a guy called as Richard Stallman. So this person, Richard Stallman, is the person who opposed that. So already we are purchasing servers, we are purchasing the devices, whatever the peripherals that we want. Again, what is the necessity for me to purchase your operating system? I will go and prepare my own operating system. Then he started his own operating system called as, do you know what is the first operating system? GNU. GNU is the first Linux operating system, but here he has failed to develop the kernel. So as I already said you that, so he has written the source code for the front-end programs, but the main backend, whatever the backbone of your operating system, he has failed to develop the kernel. When he failed to develop the kernel, he has waited from 1985 to 1991. Then there is a person called as Linus Torvalds. You know about him, right? Who is this? Who is this? Linus Torvalds, the developer of your Linux operating systems. Okay, so this Linus Torvalds has developed a kernel called as Linux. Actually, at starting, Linux is a kernel. And then what he has done, he has integrated this GNU and Linux kernel, and they developed a first operating system called as GNU Linux. They started generating a new operating system called as GNU Linux, which is a open source and free of cost. They have mentioned that it is a open source. Whoever having an extensive knowledge on C language, they can develop their own Linux operating system. So that's how the Linux operating system has started. And with that, a Red Hat organization is there. Red Hat organization has developed their own operating system from this open source operating system. And there is SUSE. And later on, we are having Ubuntu, like Debian operating system. And nowadays, I think for every day, you will get a single Linux operating system. At least single Linux operating system was introduced into the world. Okay, so like that, it might be like the Linux operating system might be what I can say customizable. So this is the background of your Linux operating system. So to develop that also, the Richard Stallman has to wait for around 6 years to get the kernel. Until Linus Torvalds didn't develop the Linux kernel, the Linux platform was not came into the picture. So this is the background. So that much important is your kernel. Now the point is we have came across all the things. Why? Because here your container, whatever the container that you are having, the container will be accessing the operating system kernel. This is the point. But now you need to understand, Here I am using a Linux operating system. For example, the container which I am running is a Ubuntu container, and the backend is my Windows operating system. The operating system whichever I am running on my host machine is Windows operating system. It is my Windows operating system. Now, how this Ubuntu will use my Windows operating system's kernel? One operating system kernel will be different from the another operating system kernel. How it is going to use that? So to work with this, whenever you are creating the Docker, definitely you need to install WSL. This application you need to install the Docker on Windows operating system, which means that Windows subsystem for Linux. If you don't install this WSL, the Docker won't be starting. So the Docker straight away gives you an error. So you need to install WSL. Without installing that, Docker won't be started. So you need to install this. What is this WSL? Again, I'm repeating, Windows subsystem for Linux. Okay. So then we can run our containers. So let me show you. Hold on. Where is it? Yeah. This is the Docker desktop. So until I start this Docker desktop, if I run this, let me show you. Docker, already Docker is there. But if I run that Docker PS, see that you are going to get nothing. So Docker PS. Sometimes you are going to get an error. Docker engine is not running. Docker daemon is not running. See that error response from daemon. So the systems cannot find the file. Docker engine Linux, the system cannot find the file specified path. But after starting the Docker engine, so let me do one thing. I will go with PowerShell. So when I start the Docker engine, so here the Docker application is started. Now, if you check here, Docker PS, so it is running. So Docker images, if I run this, I'm going to get all the images. Now Docker is running. If I close this, let me show you, I close that and I will exit from the system tray also. So what I can do, quit Docker desktop. So here you can see Docker desktop is stopped. Once the Docker desktop is stopped, now if you try to run this, you are going to get an error. Docker daemon is not running. So to run the Docker daemon or else to get any data from Docker, definitely backend daemon should be running. You will understand this in the Docker architecture. But as of now, as daemon is not running, my Windows server or else Windows client machine is unable to get the details from the Docker. So this is the main point. So in the backend, if you want to run anything in Windows, first of all, you need to run the WSL. So what are the requirements to install Docker on Windows? So I'm not going to install it now, but in the companies also, they won't ask you to run the Docker on your Windows server. They will ask you to run on the Linux servers only. So Docker installation on Windows. If you see here, open the command prompt and run the following commands. Hold on. See there. System requirements. You must meet the following requirements to successfully install the Docker on Windows. The first and foremost thing here is itself, they have said the WSL2 backend, WSL version and Windows 11 64-bit Pro or higher versions that you can use. And you need to have a 60-bit processor and 4 GB of RAM. And these are all the things that they are mentioning. And here you can see that BIOS level hardware virtualization support must be enabled. So in BIOS, you will have an option called as virtualization that should be enabled. So with that only you can run or else you can install the Docker. So this is how you can install it. Installing interactively. Docker desktop installer. So you need to download the Docker desktop installer and then see there. So you can get it from the Docker hub. If you open this from here, you can get the Docker installer. Okay. So and after that, what you can do here is you can run this particular queries. So Docker desktop installer.exe install, and then you can go with the processes. And first of all, what you need to do, you need to install the WSL. Then only you can get the Docker desktop. These are all the prerequisites that you need to maintain to install the Docker on your Windows machine. Okay, try to do that. If at all, if you don't get that, definitely I am going to show you how to install that. Anyways, coming back to the next one. So here we can install that on the Ubuntu machine also. So installing on Linux. So if you can see here, platform is Ubuntu. On Ubuntu, if I want to install the Docker, I need to run all these commands. So all these commands I need to run. So which is a very hectic thing for me. So all these commands are available in a single, what I can say, shell script, that is get.docker.com. If you go here, all the commands will be available here. Here you can see this is the shell script which is written. And if I run this shell script, automatically the Docker will be installed on my Ubuntu server. So let us see how we can install that. When I go to EC2 instances, I said that I'm going to show you. So is anybody having doubts with this? So I will show you how to create the VPC and all the things. But let me check out this. First of all, let me install the Docker. Done. Now what I want to do here is I want to install the Docker server. Where I want to install. So when you go to the EC2 in AWS, here you can install that. Look at here. Launch instance. I want to run some Docker server. Okay. So on the Ubuntu machine, I want to run it. So that is 2004. If you want to try it on Amazon Linux, find out some documentation. Okay. So yeah, if I go on saying about how to install on different operating system, it is going to take a whole lot of 5 weeks for only installation processes only. So Ubuntu server and key pair will be AWS common key pair. And I am going to install this on my Vola VPC and select an security group and test the connection. And I will tell you about this. Don't worry what we are doing. So first of all, let me show you how to install this. It is pretty simple installation. After installing the Docker server, what I can do, I can take the access of the Docker server and I can run it. So the point what you need to understand here is, so after installing the Docker, what we are going to get? What is the usage of the Docker? What is the usage of the container? So let us see. So did anybody having any understanding about the processes running on the Linux machine? How you will get the processes that are running on a Linux machine? What is the command that you will use to get the processes on a Linux machine?
ps-ef.
That is total processes. Exactly. ps-ef. In the same manner, here also docker ps means it is going to show me all the running containers. So here again, ps means processes only. So which means that docker ps, it is going to display all the containers running. So which means that ps is a command which will be used to deliver the processes that are running in your server. In the same manner, docker ps means the processes that are running on the Docker engine. So which I can correlate that the process is equivalent to your, or else the container is equivalent to your process. Okay, so now let us check out. Now, whenever I am logging into my server here, try to understand this. I just logged into my Ubuntu server. Now the point is here you can see if config. Why we use if config? To get the network adapters. Okay, so what I will do here is if config is not going to be worked out. So now what I will do, apt update -y and apt install -y net-tools. So now what I have done, if you see here, I just created a Docker server. I created a Docker server. So inside the Docker server or else on the Docker server, you will have a interface, that is Ethernet port will be there, and for that Ethernet adapter will be available. And if you see here, if config, look at there, we are having ETH0 with the IP address 192.168.1.198. Okay, so this is my Ethernet adapter, which is Ethernet 0. and that is having a local IP address. It is having a local IP address as 192.168.1.198. This is the local IP. And there is a public IP for this adapter. What is the public IP? The public IP for this server is 179. This is the public IP. Okay, good. Now the point is we did not install the Docker. Now we will be installing that. Here you can see there are two adapters only. This is Ethernet 0 and this is the loopback adapter. So any network engineers are there? So I'm a network engineer, but any network engineers, anybody know about the loopback adapter? Why we will be using the loopback adapter? If at all, if you are a network engineer, you can simply say this. Or else any other person also. If you know about that, just tell me why we use the loopback adapter. Okay. Any developer is there?
Yeah, I'm there, sir.
Okay. If you want to develop any application on your physical computer through a URL, basically at the starting time, which URL you will use?
127.0.0.1.
Exactly. So see here, what is there? What is IP here you are having?
Okay.
Okay, that is called as local host, or else this is called as a loopback adapter. Basically, loopback adapter is used for testing purpose. If you want to test any application, or else if you want to test whether your network interface card is working properly or not, then you can go for the loopback address. Okay, so these are the two types of interfaces that you are having. Now, when we install Docker, curl -s capital L https://get.docker.com bash. When I give this, automatically it is going to execute the shell script which is there here. You can see whatever the shell script is there inside this total file, that shell script is going to be executed and it is going to give me the Docker. Hold on. Hold on. So questions, guys? Are you able to understand what I am saying? Any doubts? Is it clear?
What is this curl? That's a
Curl means check URL. Curl is a
Okay.
Linux command which we are using to check. See, for example, I want to know what is the base code of Google. So what I will do, curl https://google.com. When I give this, it is going to provide me the basic Google website information. What is the HTML code that we have written? What is the JavaScript that we have written? If you copy all these things and written in a proper manner, you are going to get the basic HTML page for your Google. Okay, curl is going to get me all the whatever the content that is there inside the HTML page, or else it is simply check URL. Okay. Now, if you can see, Docker is installed. So I can go for Docker info. Look at the Docker is installed and it is running. So what is the version we are having? 24.05 is the version which is installed. Now the point is, if I go for if config, look at that. Previously we are having Docker 0, Ethernet 0. Now we are having, previously we are having Ethernet 0 and loopback. But now we are having Docker adapter. So this is called as a bridge adapter. Whatever the adapter that is created when we install the Docker, this is called as a bridge adapter. So why we use this bridge adapter? You will come to know about that. But as of now, we are having a bridge adapter. By default, this bridge adapter will be having the IP address as 172.17.0.1. If you create also, you will have the same IP address for the bridge adapter. So this is the default IP address that is allocated for the bridge adapter. Now, after that, I am going to connect this bridge adapter to my, so by defaultly what happens, this bridge adapter will be connected to your Ethernet adapter, your interface. Okay, this is the Docker networking, guys. Now, what happens here? We have the bridge adapter. Now, what are the commands that we can see? Docker network ls. If you give it, it is going to display the total number of adapters that are in the Docker console. Here you can see we are having a bridge adapter. This is the Docker bridge adapter, and this is the host adapter, which means that server Ethernet adapter. And this null, whatever the null adapter that you are looking here, this is called as your loopback adapter. So right now I am having 3 adapters only. Among those, host adapter will help us to communicate with the internet. And if you have any problem in the container, you can run the null adapter. I will show you in the upcoming sessions. Whenever we go for the persistence volumes, there I will tell you about this null adapter. But as of now, we need to understand what is this bridge adapter, what it is going to do. You know that the host adapter is for making the communication with the internet. But here comes the bridge adapter, what it is going to do. To understand this bridge adapter, I want to create a container. I want to create a container. If I want to create a container, first things first, what you need to understand here is how container will be created, how we can create the container. So to create the container, what is our requirements? You need to understand the basic Docker architecture or else containerization architecture. So we are going to provide some commands. So this side you will have the client mission. From the client mission or else from the server, you are going to fire a command. Okay, we are going to fire a command either through Docker CLI or else through Docker, what I can say, API. In Windows, you are having this Docker desktop, that is your API. Either you can fire the commands through CLI or you can fire through API. Okay, when you fire a command, I am firing a command, or else I am giving a command like docker run -rm -itd. What is this -rm -itd? I will tell you. But as of now, -itd -name. I am providing the container name. The container name is test container 1 -image. This is very important. I am going with Ubuntu or else, okay, let me go with Ubuntu latest. Now here you have some terms which you don't understand. Now the first things first, you need to check the Docker images. So every time I'm getting the response, if I give Docker PS, see here, Docker PS, what it is going to show you when I give this command. So what is the PS command you said in Linux? What is the main functionality of PS command?
Yes, the process is running.
Showing the running processes. Here you can say Docker PS means showing the running containers. Right now, no container is running. Okay, that is good. And how this is executing, because see here, when I fire a command Docker images, it is showing me something. When I fire a command Docker PS, it is showing me something. When I fire a command Docker network ls, it is showing me something. Okay, just give me a second, guys. Sorry. When we coming back to this, so it is running. Whenever I am giving any command, it is displaying something. How? Because whenever we fire a command, this command will interact with my Docker daemon. Previously, when I shut down the Docker daemon, I am unable to connect. So in the Windows, I have shown you. In the same manner, in the back end, in our Linux also, in the back end, you will have the Docker daemon. This Docker daemon will be helping us. Whenever we are working with this is the Docker daemon. So our CLI will be interacting with the Docker daemon. If you run any command, that will be fired to the Docker daemon. Now, when you are giving this run, pull, or else if you want to commit anything, is going to be sent to the Docker daemon. So this Docker daemon will communicate with the images that are there in the local server. So if you see here, in the local server, we will have some registry, image registry, which is going to be there in the local machine. Right now we are having, do we have any images? See here, Docker images. When I fire the command, do I have any images? Right now it is showing null, repository tag, image name, image ID. It is not showing anything, which means that in the local machine, I don't have any sort of images. So here I can keep it like a null. We don't have any images. And here, this is my registry, image registry in the local machine. And next one here is Docker images. And with the help of these images only, the containers are going to be created. With the help of the images only, the containers are going to be created. For containers, we will be having separate space. Okay. So this is my Docker containers. Okay, when we have this Docker containers running, what happens when we fire the command will be reaching to the Docker daemon, and the Docker daemon will allow us to communicate, or else the Docker daemon will communicate with the local image registry. It will communicate with the local image registry if it finds the image inside the registry. Right now, we don't have any image. Then if it finds the image, it is going to create the container. Right now, we don't have any image. Then what it is going to do here is the Docker is going to communicate with it with its own registry called as global registry called as Docker hub. So the Docker daemon will be automatically calling, or else it will be sending a request to the Docker hub. In the Docker hub, you will have all your registries and repositories. Inside the Docker hub registry, you will have multiple repositories. Inside the repository, you will have multiple Docker images. These are all the Docker images that are available inside the repository. Okay. So then what it is going to do? It is going to pull the image from this Docker hub registry and store it on the images. Here you will have the local images. So there it is going to store it. See here. And by this image, it is going to create a container. By this image, it is going to create a container. So now this is what we have to do. See here, this is the container which I am creating. For example, test container 1. Test container 1 is what I am creating. Now, if you see here, I have given the command docker run -rm -itd. I will tell you, I will clearly explain you. --name test container 1 -image Ubuntu latest. Okay, so now what happens here? Docker will understand, okay, I have to create a container with the name test container 1. So I'm going to create it. So how I have to create this container? So if you are having if you have a computer, now if you want to run any application, whether you are going to run the application directly on the container without installing any operating system, or else without installing any operating system, or else any application, are you directly going to run the application? It is not possible. In the same manner, if I want to create a test container, I need to have a base image. This base image will have the operating system and the applications that are running. So the Docker want to create the test container with the image called as Ubuntu latest. So when I give enter here, do I have any images in my local registry? I don't have any sort of images in my local Docker registry. So if I press enter here, it is going to show you, oh, come on. So no need of information. This is the Kubernetes one. I forgot. Hold on. So when I press enter here, see that what it is saying? Ubuntu latest locally, unable to find the image Ubuntu latest locally. So what it is doing? Pulling from library Ubuntu. Where is the Ubuntu library available for me? If you see here, hub.docker.com. If you go here you can see this is the Ubuntu. If I go into this is my Ubuntu library. Inside this Ubuntu library, you are having the Ubuntu missions or else Ubuntu images. So if you can see, this is the Ubuntu latest image that it has pulled out. Whatever the image that you are seeing here, Ubuntu latest, this image is the image that is stored in the Docker Hub, and this is the image which it is pulled. Now, whenever it is pulled, now here you can see Docker. If I go for the Docker images, here you are having Ubuntu image. Previously, we don't have any local image. Right now, what it has done, it has pulled the image. And if you can see here, Docker PS, we are having certain container running. Here you can see the container is running, and you will learn about the commands in the upcoming sessions. Whenever we are creating the Docker image files, you will know about that. But as of now, a container is running. So this is the architecture diagram. Right now, if you can see what happened when I fired the command is reached to my Docker daemon, and from the Docker daemon, it searched in the local repository or else registry. In local registry, I don't have the images. It just pulled the images from the Docker Hub, and then it created a test container one and stored the images in the local registry. This is what happened in the backend. So this is the Docker architecture. Understood? Guys, do you understand this?
Yes.
So if you see here, this is the Docker architecture. Client is communicating. He is trying to pull the image, or else he is trying to run the Docker container. It will be communicating with the Docker daemon. The Docker daemon will search for the images. If the images are available, it is going to create the container. If the images are unavailable or not available, then what it is going to do? It is going to get the images from the Docker Hub. Okay, sir, if we don't have the images in the Docker Hub, then what we have to do? I am expecting this question. So you said that we have the images in our local registry, and you said that we are having the images in the local or else global registry called as Docker Hub. If we don't have the images, then what we have to do? Then obviously we have to build it. We have to build our image. How we have to build it, I will tell you in the next session. But as of now, this is how you can run your container. Am I clear with the Docker architecture? Any questions?
Yes, sir. But why did we use AWS here, sir? I didn't understand.
Why did we?
Use AWS.
Where is my server running?
No, can we directly run Docker in our machine? Why did we use AWS?
I
for
don't
that?
have the virtualization. If I have virtualization installed on my laptop, I can run directly on the virtual machine only. Okay. Why I have to go for AWS? So if I go for AWS, then that will be very easy for me to save. If you want, you can run your virtual machine and you can install the Docker in the same manner. That's totally your wish. Okay, I am
Means for
using
that we need, what should I do, sir, if I want to do in local?
local. So if you are having the Windows machine, in Windows machine also I can run the same. So you have to install the Docker desktop. It is a
Okay.
simple thing. So right now Docker desktop is not there. If you want to run on your Windows machine also, you can run it out on the Windows machine. But for that, you need to install the Docker desktop. When you install the Docker desktop, you can run the same commands on your command line also. What is there?
Okay.
Yep. Okay, so for the architecture is common. Again, don't ask me that, sir, Windows have any different architecture. For any operating system, the Docker architecture is the same. Okay. If you want to search in the ECR, that's a different process that you have to do. Elastic Container Registry. Then you need to, so if it is a public, so I don't think AWS images are public images. We don't, what I can say, I don't, especially I am taking in my case, I don't openly share my images. Okay, whatever the images that I store in the ECR, those will be private registries or else private images. So first of all, you need to connect to the AWS services. For that, you need to install AWS CLI, and after that you need to pull the image from the AWS CLI. The process is same. You need to have an AWS ECR registry, and after that you need to create an image in that, and you need to pull that. Here the command is same, docker image pull, and the command is same, but the point is you need to connect to the AWS ECR. That is the only thing that you need to do. Okay. I will tell you this ECR concept in the AWS EKS, which we are going to learn in the at the end of the Kubernetes sessions. Understood? Any further questions, guys? Okay, let us go back to the, yes.
What question? EC2 is a Docker image, or it is what kind of image it is?
EC2 is a virtual machine. EC2 in AWS is a virtual machine.
In AWS, yeah, I know that.
Yeah. Then why again asking you? EC2 is a what is that image or?
It's a like a what kind of like in a virtual machine, right? How come? What kind of?
So you don't have the clarity in your question.
When you spin it, automatically operating system will automatically operate along with the
Sorry.
hardware. It will be spin, right, when you spin it.
Spin it. See, ask the question confidently and clarity. You need to maintain the clarity. There is a very big ambiguity in your question. So what you are asking?
No, my question that EC2. So in our AWS, we have EC2, S3 kind of thing.
Don't
right?
get S3 and all the things here. We are working on EC2 first. Okay, you don't need to get S3. Yeah, what is your question? We have an EC2.
It like image is like container, like a when you take the EC2, means when you purchase EC2 in AWS.
I said you that EC2 is a virtual machine only. So where you are going to get the image from the AMIs, Amazon AMI, Amazon Mission Image. With that, you are going to create the EC2.
Okay.
So here what we are doing, whenever we are creating an Amazon EC2 instance, it's a virtual machine, guys. So here from this AMI, we are going to select this. See here, when I try to launch the instance, here I will provide the name. Here we need to select the Amazon Mission Image. If I select the Ubuntu, it is going to come with Ubuntu operating system. If I select Amazon Linux, the EC2 instance will come with Amazon Linux instance. If I go with Windows, it is going to come with the Windows operating system. So here I have to select the Amazon Mission Image. Don't compare Amazon Mission Image and Docker images. Okay, Docker image is the image that is a lightweighted image which is created for the Docker purpose. And these images are for the Amazon, these are the Amazon Mission image. Those two are different. Again, don't compare, both of them are the same. Okay, with this image, I can create my EC2 instances. Understood?
Yes.
Okay. That's about your Amazon EC2, how you are going to create your Docker and how you are going to launch the EC2 missions. But we have just came out of the topic. So we understood about the Docker architecture, but the main point is why I have created this container. What is the necessity of creating this container is, so when we create the container here, this is what the topic that we are discussing. When we create a container in the Docker, this container will be connected to my Docker bridge adapter. So which means that this container is going to get an IP address in the range 172.17.0.2 will be the IP address of this container. And whenever it wants to communicate with the internet, when the container has to get some updates or else it has to install something, if the container has to communicate with the internet, then this container will send a request through the bridge adapter, through the normal adapter to the internet. This is how the containers will communicate with the internet. Now, if you can see here, let me show you that. Now the container is having the IP address, right? So what I can do here is, hold on. Now, if you can see here, Docker PS, I am having a container running, that is test container 1. Now I can go with Docker network. What are the networks that I am having? Docker network ls, I am having a bridge adapter. If I want to inspect that, inspecting means if I want to search, or also if I want to investigate, Docker network inspect bridge. If I give the name of that particular adapter, it is going to display several things. Here you can see what it is displaying. The name of the adapter is a bridge adapter, creation time, and the driver is the bridge adapter. And what is the configuration? The adapter, the bridge adapter subnet is 172.17.0.0, and the adapter gateway, which means that the whatever the data that has to come into the Docker network, and if the data that has to go outside of your Docker network, the gateway will act like an entry and exit point. Simply, if anybody wants to enter into your home, or else if anybody wants to, or else you want to enter into your home, first of all you have to open the gate. If the gate is not open, you cannot go into the home, and as well as you cannot come out of your home. In the same manner, gateway is also like, it's an entry and exit point for your Docker data. So what is the gateway? 172.17.0.1, which is assigned to your bridge adapter. Here I have shown you. So if any data, if this Docker container wants to communicate with the internet, it will go through the Docker adapter only. So after that, what it has given here, here you can see, it has given the containers. What are the containers that are running? Test container 1 is the container which is running with the IP address 172.17.0.2. So this is the test container IP address. So which means that, so if I try to log in into the test container, so how I can log in into this, or else how I can enter into the container? So to enter into the container, Docker execute -it. What is the test container name, or else container name? Test container 1 bash. If I give this command, now previously we are on the server. You can see the server IP here. Right now we are in the container. Okay, this is the container ID. Now here, what I can do, I can run apt update. Why I have to run this? If you see here, basic utility is also not going to be there. So if you see Docker images, what is the size of the image? Only 77.8 MB of operating system size is there. Your Ubuntu operating system, basic operating system size is 77.8 MB is there. So nothing will be there. So if you can see here, Docker, sorry, if config, if I go for if config, not available, ping not available. So no application is, basic utilities are also not going to be there. If I go for ns lookup, not found. So no basic utilities will be there. We have to install them. So apt update -y, which means that first of all, I want to update my Ubuntu repos. If I want to update my Ubuntu repos, what I have to do, first of all, apt update -y. When I provide this command, this container will communicate with the internet. How it is going to communicate with the internet? Through the bridge adapter. Let us see. There you go. Done. So now apt install -y net-tools for if config, iputils -ping for the ping command. If you want to install anything else, you can install that. Done, guys. Now if you go for if config, I want to know the IP address of this container. See here, what is the IP address? 172.17.0.2 is the IP address of the container. Okay, the container IP is this. Now control PQ, if you press this control PQ buttons, then automatically you will be coming out of the container. So which means that now you have understood that how containers will be working and how they will be communicating with the internet. So if I create another container also, if you can create n number of containers, you can create n number of containers. By defaultly, they will be connected to the bridge network only. Now see here, Docker run -rm -itd, or else if I don't give -rm, what is going to happen? -itd and -name of the container is test container 2, and the image will be, again, I will be working with Ubuntu latest only. Okay, right now Ubuntu latest is available in local, so it is not going to pull the image from the Docker Hub. See here. Directly the container is creating. Previously, what we have unable to find the image locally, so it is pulling the image from the Docker registry. Right now, image is not is available in the local machine itself, so it is not going to pull it. Now you can see here, Docker PS, 2 containers are running. One is test container 1 and the other one is test container 2. By defaultly, these 2 containers are interconnected with the bridge adapter. Here you can see they are interconnected with the bridge adapter, and the IP address that is going to be assigned for this container is 172.17.0.3. Okay, this is the IP address that you are going to be assigned to the container. Now what I can do here is, look at here, docker execute -it test container 2. I am going into the test container 2 bash. Now can you tell me whether the whatever the apt update or if config or else ping commands are available inside this container? Can anybody say me if config and ping utilities are available inside this container?
No, it's not there.
Exactly. Thank you. Thank God. So those are not available. Why? Because this is one utility. This is a container and this is the another container, which means that these two are in the ISO. Sorry guys, there is a sudden drop in the network. Yeah, what we are discussing here is Nishant, you need to wait for that. Whatever you have asked me, you need to wait for that. In the next session, I will tell you, I will give you a clarity, or else let me see. Right now also, I can provide you the clarity about that. So now what we are doing here is, right now some containers are running, right? So what are the containers that are running? Docker PS. Here you can see test container 1 and test container 2 are running. Now the point is, if test container 1 can be able to communicate with test container 2, first of all, I need to understand what is the IP address of test container 2. To get the IP address, what I can do here is docker inspect or else docker, or else I can go with the inspect, docker inspect test container 2. So if you can see, the IP address of test container 2 is 172.17.0.3. Okay. Now let me log into my docker test container 1. Docker execute -it test container 1 bash. Now if I try to ping, see that I am getting the response from the docker container 2. So which means that with the IP address, we are able to communicate. The communication will be able to establish between these two containers. This is the first point that you need to note down. And the next one here is docker test container 2. If I give with the namespace, so I am giving it the naming convention. If you see here, sorry, I am going with the docker. Come on. Ping test container 2, what it is saying, name or service unknown. We are unable to catch not known. So what is the test container 2? We are unable. So the docker container is unable to know that. Then what is the solution for this? So there is something. So see here, what you need to understand is there are sometimes what you need to do here is you need to communicate between the containers with the namespaces, with the naming conventions. For example, there is an application server. That application server has to communicate with the database. Sometimes we have to provide the name. In the URL part, you need to provide the name. So with this Docker container or else with this particular database, you need to communicate. That should be in the name. So, but here you can see that through the naming convention, Docker is unable to, or else the container is unable to communicate. For that, what I have to do? Do you understand the problem here? Guys, do you understand the problem? Can you repeat what is the problem? Can you say what
Yes,
is the
yes.
problem? So
Yeah, we are not able to,
go on.
we are not able to access with the container name. We are able to access with the IP address.
Exactly. We are able to access with the IP address. Now, what is my requirement? I want to communicate with the name also. Then what I have to do here is, let me come out of the container here. Here, I am going to create one external adapter. Again, one more external bridge adapter I am going to connect. So this is my customized or else user created adapter. This is the adapter which is created by your Docker. Now this is the adapter which is created by the user. Now let us create that adapter. Docker network create adapter name is external and the bridge adapter type is bridge, or else create here I can give adapter type is bridge adapter. Let me give this only external. If I give this, see there, Docker network ls. If I give this, see here, external adapter is created. Now what is the IP address that is assigned to this adapter? Here you can see whenever we create the Docker, automatically we have the so automatically the default IP address assigned to this adapter is 172.17. So here the new adapter will have 172.18.0.1. So this is the adapter IP that is assigned to the new external adapter, and you can change that also. That you need to find it out. So you can change the external adapter IP address also. So how we can change that? That it just find it out. If you don't find that, I will tell you in the next session. But as of now, let me do one thing. Docker network inspect. I want to inspect the external adapter. Here you can see what is the IP address that is assigned to the adapter, 172.18.0.1. Now what I can do here is, what are the containers that we are having? We are having test container 1 and test container 2. I want to connect my test container 1 and test container 2 to the external adapter. So how I can connect that? If I want to connect these two containers to the external adapter, first of all, I need to disconnect these two containers from the bridge adapter. Okay. See, if you want to join in the DevOps, or else if you want to join in a team called as DevOps, and right now you are in the development team, what you have to do? First of all, you have to relieve from the development team, and then you have to join in the DevOps team. In the same manner, here it is going to relieve from this default network adapter, and the containers has to join in my external adapter. The containers will be joining in the external adapter. Now, what happens here? Let me first disconnect that Docker network disconnect test. What is the adapter default? Sorry, bridge. This is the name of the default adapter. Test container 1, and then test container 2. When we have disconnected these two containers, here you can see Docker network. Or else let me inspect the containers. Docker inspect test container 1. See here, there is no IP address for the test container 1, which means that it has been disconnected from the bridge adapter, and it is not connected to any another external adapter also. It has been disconnected from the bridge main default adapter, but it is not connected to any another external adapter also. If you search for container 2 also, the IP address is not there. Now, what I can do here is Docker connect, sorry, Docker network connect test container, sorry, external to the external adapter. I need to connect test container 1 and test container 2. So I'm connecting two containers to the external adapter. Now here you can see Docker inspect test container 1. Now you got the IP address as 172.18.0.2, and for test container 2 you got 172.18.0.3. Now let me log in into that containers. Docker exec-it test container 1 bash. Now if you try to ping test container 2, look at here, ping test container 2. There you go. You are getting the response from the test container 2 through the name also. Previously you got from IP address only, but now you are getting from the name also. Okay, so excuse me, this is how you can connect to the containers, or else this is how you can make the connection between the containers through the name also. Understood about the networking part? Any questions?
Sir, but why is the difference, sir? Both are bridge adapters only, right?
But
No, why is the difference? Like one is normal, like initial bridge adapter, we are not able to ping. But this is external adapter. That's why we are able to ping using the name. That's all.
exactly. This is the external adapter which is helping for us to communicate with your containers through name. Okay. Final mode is to communicate with the adapter that is happening. Okay. So that's
One more thing
about your.
So AWS, we have created the server, Docker server, and you are doing all this logging in and all these images. So these images are all getting created within AWS server, sir, AWS Docker server.
No, you can create in your Windows also. You can create in your virtual machines also. So the image you are talking.
Just for this, whatever you are doing, these are created in the Docker server in the AWS, right?
Yeah, you are asking about the Docker installation and Docker containers where they are creating, right?
Yeah, in your today, whatever we are discussing, that ones.
That you can do in your normal computers also. So not only, so this is a medium which I am having right now.
Okay.
See, the thing is, now if I want to run here, look at here. Docker, let me do one thing, PowerShell. Now what I can do,
so real time, they will be using this AWS only, you are saying, sir?
In the cloud, they are using, especially. You can use in your on-premises also, but majority number of the cases you can use in the cloud. So if you want to run on your computer also, that is what I am saying, Docker run -itd. I want to run a container -name test container 3 or else image will be nginx latest. I can create this. See here. Look at that. Docker PS container is created. Now it is running. So anywhere you can run that, but most probably we will be using the containerization in the cloud consoles or else cloud like what I can say AWS or Azure. That is the reason I am directly deploying that on your AWS missions. Okay.
Okay. Okay.
Yep. Any further questions, guys? Do you understand that?
So
Yes.
what I understand from external
Mhm.
adapter and internal adapter, right? So
Mhm.
when we create that external adapter, it is created with a different network, right?
Yeah, that is
I'm
created with a different network.
okay. Is that because of we are able to ping the another image or another container?
Of course, you can say that.
Okay.
Okay. So both adapters are of different network IDs only. So if you want to have the naming communication, you need to have an external adapter. Okay.
Okay.
So this is the primary thing, basic thing. Okay. So why what that is totally given by the Docker itself. They have mentioned that we can communicate with the external adapter. Now, if you go to the Docker documentation also, they did not give why and how it is happening. So if you go to the Docker documentation also, hold on. Okay. Now, if you go to the Docker networking, here also they did not provide the exact definition why it is connecting, why it is communicating. They said that with the external adapter you can communicate. You don't find that also here. So they see that DNS services by default containers inherited DNS settings of the host and as defined as /etc resolve the configuration file. The containers that are attached to the look at there. The containers that are attached to the default bridge network adapter receive a copy of this file. Containers attached to the custom network use the Docker embedded DNS server. The embedded DNS server forwards the external DNS lookups to the DNS servers configured on the host. So whatever the custom network that we have created, they will have the DNS records. So they can communicate, but the bridge network won't have that. The resolve.config is not available. So that is the reason we are going for the custom networks. Am I clear with this? If you go through this, you will understand one thing. Okay.
Okay. Yeah.
Yep.
Thank you.
Yes. So that's about your Docker networking, guys. Right now, I hope that I made it very clear for you how Docker will be installed and how Docker will be worked out and what are the things that we have to install to run the Docker containers, Docker networking concept. And one more thing, what we can do here is we can establish the communication between the two networks also, between the default network and between the external network also. But we need to allow that through the firewall. Okay, you will come to know about that. But this is the basic sessions which I am providing. So with this, I'm stopping the or else Docker concepts here. In the next session, we will be going in depth into the container creation, container lifecycle, images. So next weekend, you will have the containerization, container images, container lifecycle, and then we will be working with, if at all possible, Docker volumes and Docker Compose, Docker Swarm. So next week, at any cost, we are going to complete the Docker. So by next 2 sessions, we are going to complete the Docker if possible, or else the next week we are going to complete the Docker and we will be diving into the Kubernetes. Am I clear with this?
Yes.
And one more thing that you need to habituate here is everything will be configured on the cloud only. So we are not going to work on the on-premises or else on our computers. We are directly working on the cloud only. Why? Because to set up the Kubernetes cluster, our servers or also our laptops are not supporting. Why? Because to run that, we need to have 2 CPU for each and every server and minimum of 2 GB of RAM is required. If I want to deploy a 3-node cluster, which means that there will be 4 servers to be deployed on the Kubernetes, 4 into 2, 8 GB of RAM should be there. And you need to run the virtual machine on your laptop and as well as your operating should be running. So overall, if you have 10 to 12 GB of RAM or else if you're having 16 GB of RAM, then you can create your own cluster. but I don't suggest you to create the cluster. Why? Because we are working with the COPS. COPS is only help you to run on the cloud. So please try to understand the cloud basics. Okay, so whatever the servers that we are running from today, day 1 onwards, we will be running on the AWS only. Am I clear?
Yes.
Right then. So that's all for today, guys. And this is the last demo that I am providing for you. And from the next weekend onwards, whoever has enrolled for the session, they will be opted, or else they will be given with a custom URL or else custom GoToMeeting. With that, you are going to join into the meetings. Am I clear? Have a nice day, and we'll
Yes.
meet in the next session. Bye, guys.
Yeah, thank you. It's a nice session.
Thank
Yeah.
you. Yes, thank you.